Okay, so this is the third video in the series for your math review, and this time I'm going to tackle scientific notation and changing numbers from regular numbers into scientific notation numbers and taking them back out again as well. So let me try the first one. So the first one is 108 million. So the first thing you want to do when you turn to scientific notation is you want to put an arrow behind your first number that is not a zero. So my first number that's not a zero is 1. And I draw a line behind it. And then I want to go from the decimal place. How many spaces does it take me to get to this arrow in between the 1 and the 0? So there's no decimal. So if there's no decimal, you know you want to draw a decimal at the rear and then count how many spaces, and do not count the commas, because remember the commas are just there to show you placeholders of separating the ones from the thousands from the millions. Okay, so 1 space, you're counting in between the numbers. 2 spaces, 3 spaces, 4 spaces, 5 spaces, 6 spaces, 7 spaces, and 8 spaces till I got to that arrow in between the 1 and the 0. So I moved 8 spaces, and this is where my new decimal is going to be, right here. And you want to cross out all those zeros that are by themselves that weren't trapped. So none of these were significant. So all of these zeros are going away because they were not trapped there by decimal. Remember, we had no decimal at the end, and there's zeros at the end of a whole number. So none of those are significant, and they all go away. So what we have left is, let me draw this in red, black and red actually. So we have 1.08. Okay, so what numbers we have left that are significant? Your scientific notation exactly matches up with which numbers are significant. Times, always times 10. Okay, power of 10, because that's what our number system is based on. And then we moved 8 spaces. Now, if we look at this number originally, it was 108 million. That number is a big number, and so it gets a positive exponent. Remember, large numbers have positive exponent, so it's a positive 8. So when we write this number in scientific notation, 1.08 times 10 to the 8th, and that's it. We are done. Okay? So remember, you got to look at your numbers when you're changing scientific notation, just like significant digits. If zeros are trailing at the end and they do not have a decimal place on a whole number, then they are crossed out and they are not significant. Let's try another one. This time I have 0.12340608800. So now if I first look at this in terms of significant, well, I know the 6 and the 8 are significant because they're not zeros. And I know this 0 is significant because it's trapped between the 6 and the 8. And then I know these 2 zeros right here are significant as well. So these numbers all at the front are significant, and these are the ones that are not significant. So those are the ones that are not going to show up when I write my scientific notation. Okay. So then I want to count from my original decimal to my new decimal. I'm sorry, and let me put, I always start, my end my count is after the after the first number that's not a 0. Okay, so all of these are zeros. I want to start after the first number. So 1 space, 2 space, 3 space, 4 space, 5 space it took me to get there. Okay. And then what do I have left? Okay, you're writing your significant digits, basically. Let me change the color back to black. So your answer will be 6.0850. I'm sorry, 00, not 5. 00. Okay, so this part right here, okay, this is the part you needed for your significant digits, times 10 to the 5th power. Now remember the rules. If you're writing through your scientific notation correctly, this number is going to be between 1 and 10. The first number always has to be between 1 and 10. It's always raised to a 10th power because that's what our number system is based on. Now I put to the 5th, but this number right here is small. So if your exponent is for a large number, it's going to be positive. If this number is a tiny number, if it's less than 1, then it'll be a negative 5th. It doesn't want to draw the negative. There you go. So 6.0800 times 10 to the negative 5th, because this number was very small. So your exponent becomes a negative. Does not mean the number is negative. The negative exponent means this is going to be a small decimal, a very small number. Okay, let's look at another one. Let's look at another decimal. 0.00007 zeros I wrote this time. 7? Yes, 7.4. Okay, I want to put my arrow behind the first number that's not a 0. So first number that's not a 0 is 7. And then I want to look for my significant digits. Well, all of these zeros in the front are not going to count because they're not trapped by anything. There's no whole number in the front. It's less than 1. So none of those zeros are going to count. So I'm going to start right here at my decimal place and count how many spaces till I get to my arrow. So I'm going to start counting. 1, 2, 3, 4, 5, 6, 7, and 8 spaces till I get to my arrow in between my 7 and my 4. So I went 8 spaces. And I went to the right, so if it helps you to say to the right. Me, I just look at the size of the number to figure out what to write. So then my decimal is 7.4 because that's what I have left. Always raise times 10 to the 8th this time, but it's going to be a negative 8 because the number I started with was less than 1. Small number, negative exponent. If it helps you, this time we went to the right, right? So for the 8, we went to the right. For the 5, we went to the right. But when we had that positive 8, we went to the left. Okay, whatever works for your brain. Me, I go, oh, it's a big number. That's positive. If I put a big number in my bank account is going to go up in positive. This number, tiny, 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 that's not going to affect my negative bank account at all. You have some little ton of money again in your bank account's still going to be in the negative, right? This one's a little tiny number. It's going to not affect my bank account. It's still going to be a negative number. Let's try another big number. 6 billion and 9 million. 6 billion and 9 million. There's my number. Okay, so the first thing I want to do is I want to put an arrow after my first number that's not a 0. So that would be 6. So that's where I know my decimal needs to go. My decimal needs to go after the first number that's not a 0. And now this time I have no decimal place. If I have no decimal place, it always goes in the rear. And then I want to start counting how many spaces till I get to that space. 1, 2, 3. Don't count those commas. They're not numbers. 4, 5, 6, 7, 8, and 9. So I moved 9 spaces, this time to the left. Okay? And that's where my new decimal is going to go. My new decimal is going to go right there. And now I need to look at my significant figures. Well, this wasn't held by it. There was no decimal there to start with. So none of these zeros at the end count because they were not held in by anything. Why you want to do scientific notation is you want to write this number easier to write. Okay, look at how big this number was, and look how big our scientific notation was. It was much easier to see and calculate with. So my new decimal point is right there after the 6. So my new decimal is 6 point. I need to keep these zeros because they're trapped. They're significant. So 6.009, always times 10. And this number this time was huge. It was a really big number. So this is going to be a positive 9. And that's it. You converted it to scientific notation. Okay. So let's try a different one. Let's just say it's 2,000 with a decimal at the end. So simply 2,000 with a decimal at the end. So this counts for anything with a decimal at the end. Okay. So same rules. I want to put my arrow after the first number that's not a 0. Okay, so that would be 2 would be my first number that's not a 0. And my decimal is here for me this time. So I just got to count for my decimal how many spaces till I get to my arrow. 1, 2, and 3. So I move 3 spaces to the left this time. Now this time, before I got rid of these zeros at the end because there wasn't a decimal trapping them in place. This time there is a decimal trapping in place. So I have to keep all those decimals when I'm writing my scientific notation. So how you write it is you write 2, your new decimal is right here, right between the first 2 and the 0, the only 2. And then we keep these 3 zeros. 1, 2, 3 zeros. If they're significant, I have to keep them. So if you want to figure out your number significant digits first, and then you can write your scientific notation. Okay, so it's going to be times 10 and 3 spaces. Would $2,000 be positive in your bank account? Yes, it would. So it's a positive 3. So that's your final answer. 2.000, those zeros were all significant because they were trapped by that decimal, times 10 is third. Okay, so if you want, it helps you, do your significant figures first and then write your scientific notation, because your significant digits are going to tell you exactly how many you need to write. How many numbers need to be right here in this number with the decimal. Okay, so if you work on that first, then you have your solution. Okay, that's it for this one. Next time I'll tell you how to convert from a regular number, to a scientific notation back into a regular number.